Let's talk about the midpoint formula. The midpoint formula is a way to calculate the point that is in the middle of a segment if it's graphed on a coordinate plane. So in order to use the midpoint formula, we're going to need to know how to identify the coordinates of points on the coordinate plane. So pause the video for a second and write down coordinates for each of these 6 points are. Give it a try. Let's see how you did. Point A is 5, 2. Remember that when you're stating the coordinates of a point, the x value comes first and the y value comes second. So when I'm counting where is A on the coordinate plane, I start at the origin, the point 0, 0. And I count how far left or right it goes, that's my x value, and I count how far up and down it goes, that's the y value. So from the origin to get to A, I need to go 1, 2, 3, 4, 5 points to the right. Going right is a positive motion, so I said that the x value for A is 5. And then from there I need to go up 1, 2. Going up is also a positive motion, so I said that the y value of that coordinate was 2. You put these two numbers together with a comma in between and parentheses outside, and that's how we state where on the coordinate plane a point is. So the coordinates for B would be -7, -2, because I go 1, 2, 3, 4, 5, 6, -7. Going to the left is a negative motion, that's how I got a -7. And then I would go down 2. Going down is also a negative motion, so that's how I got -2. Point C's coordinates are 0, -6. 0 is because it didn't go left or right at all from the origin. I didn't have to go left, I didn't have to go right. I went 0 units left or right, so that means the x value is 0. Another way to think about that is it's on the axis. It's not out here somewhere like all the other points, therefore the x value is 0. The y value is -6 because from the origin I would count down 1, 2, 3, 4, 5, 6, and down is a negative motion, so -6. D is the point -3, +10, because I would go to the left 3, which is -3, and up 10, which is +10. Point E is 8, 0, because I would go to the right 8, and then I don't go up or down at all. I'm already where I need to be, so the y value of this point must be 0. And last but not least, point F is 4, -9, because I would go to the right 1, 2, 3, 4, so +4, and down 9, so -9. If you don't feel confident in your ability to do this, then you need to pause the video now and go get extra practice on identifying the coordinates of points, because that is an essential skill for what we are doing today. What we're doing today is the midpoint formula. It finds the point that divides a segment into 2 congruent segments. You can think about it like the point version of a segment bisector. Remember that from a few lessons ago, a segment bisector is a line or a ray or a segment that divides a segment in half. The midpoint is basically just where the segment bisector intersects that segment. In a coordinate plane, we use this formula to calculate the coordinates of a midpoint, which looks way more complicated and scary than it actually is. All that this formula is telling me is that the midpoint, x, y, are going to be its coordinates, can be found by averaging the x values. I add one of the x's to the other x value and divide it by 2. And averaging the y values. Add the y's together, divide it by 2. Let's take a look. I want us to calculate the coordinates of the midpoint of this segment AB. In order to do that, we need to know the coordinates of the endpoints. A is the points -8, 5, because I would go 1, 2, 3, 4, 5, 6, 7, 8 to the left, which makes it negative, and then up 5, so positive. B is the point +6, +5, because I would go to the right 6 and up 5. You'll notice I also labeled underneath of the numbers with x1, y1 and x2, y2. Remember that x and y are always the letters that we assign to each of those coordinates. X comes first, y comes second, just like in the alphabet. And I put 1s on the first point, and I put 2s on the second point. That's all the little baby numbers, these little, what they call them, subscripts. That's all that those numbers mean. It's a way to label which point is which. So the ones with 1s are the first point. The ones with 2s are the second point. And labeling your numbers like this makes it really easy to fill in your formula. So let's do it. My midpoint is x1 and x2. So x1 was negative 8, x2 was positive 6. So I have negative 8 plus 6. Then I'll divide that by 2. Write a comma. And let's do the same thing for our y's. Well, actually, both of our y's are the same number in this case. I have 5 plus 5. And divide that by 2. So now I just need to simplify these big fat fractions. Let's do it. Negative 8 plus 6 is negative 2. And 5 plus 5 is 10. Now if I reduce each of those fractions, I get my answer of negative 1, positive 5. I always encourage you to go ahead and do what I just did, which is plot that point on the graph to make sure that it makes sense. Because if we had gotten, the point 5, negative 1, that would be 5, negative 1, that's all the way over here. That wouldn't make sense. It's not even on the segment. Always plot your point afterwards and make sure that it's on the segment and appears to be about halfway in between those two endpoints. Now you might be looking at this problem and saying, I didn't need a formula for that. It's horizontal. I can just count halfway in between. Like I can just be like A to B, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's 14 units long. Half of 14 is 7, so I can just go 1, 2, 3, 4, 5, 6, 7, and what do you know, there's my point. And you're absolutely right if you thought that. And that's true if it's a horizontal line or if it's a vertical line. But if it's a diagonal line, you can't really count it anymore. You have to use the formula to make sure you're finding the exact coordinates of the midpoint. So again, the first thing I need to do is identify the coordinates of my endpoints. I've got 1, 2 for the coordinates of C, and 7, 8 for the coordinates of D. And I'll just take those numbers, which again I labeled as x1 and y1, and x2 and y2, and plug them into my formula. The midpoint is equal to 1 plus 7, that's x1 plus x2 over 2. And 2 plus 8, that's y1 plus y2 over 2. 1 plus 7 is 8, 2 plus 8 is 10. Reduce those fractions, and I get 4, 5. Which, again, if I plot it on my coordinate plane, it looks pretty reasonable to me that the point 4, 5 is about halfway in between point C and point D. Let's try another one. Point E has the coordinates negative 6, negative 8, and point F has the coordinates 0, 3. So plugging those numbers into my formula, x1 plus x2 is negative 6 plus 0, and y1 plus y2 is negative 8 plus 3. Negative 6 plus 0 is obviously negative 6, and negative 8 plus 3 is negative 5. Now you'll notice something a little bit different when we simplify the fractions this time. Negative 6 divided by 2 is negative 3, that's no big deal, but negative 5 divided by 2, that doesn't divide evenly. So just go ahead and give it as a decimal version of your answer or a fraction version of your answer. I really don't care which one you give me, but it isn't going to be an integer this time. And that's totally normal. You're actually going to see that pretty frequently, about like maybe 50% of the time with midpoints, because you're averaging two numbers and maybe they're divisible by 2, maybe they're not. It's going to be okay. If you get a decimal, the world will keep turning. And the good news is you don't even have to have a coordinate plane in order to use the midpoint formula. Even if I just tell you that these are the coordinates of my endpoints of a segment, you can calculate the midpoint using the formula. So I'm going to label point P as x1 and y1, and point Q as x2 and y2, and plug in the formula. So the midpoint is going to be equal to 1 plus negative 7. Feel free to write that as 1 minus 7 if you prefer, over 2, and negative 4 plus 10 over 2. 1 plus negative 7 is negative 6. Negative 4 plus 10 is positive 6. So the midpoint for this segment is negative 3, positive 3. So for problems like this where you're not given a coordinate plane, it's a little bit easier and a little bit harder. It's easier because you didn't have to figure out the coordinates for yourself. They were already given to you, so there was no counting required, so that's nice. But there's also not a super easy way to check your answer because there's no coordinate plane to graph everything on. So if you want to check your answer, just go get some graph paper and plot everything and see if it works. Alright, let's try one more problem just to make sure that we got it. Again, this doesn't have a graph this time, we just have the points stated for us. So I'll make sure to label them as x1 and y1, and x2 and y2. And I'll just plug everything into my formula. So adding my x's, I have 9 plus 8. And adding my y's, I have -1 plus -6. Again, you can write that as -1 minus 6 if you prefer. 9 plus 8 is 17, and -1 plus -6 is -7. Now, neither of the coordinates divided evenly for this one, so I get 8.5 and -3.5. Those are the coordinates for my answer. So that's the basics of what you need to know about the midpoint formula. In our next lesson, we're going to be kind of flipping things around a little bit. I'm going to give you the midpoint and one of the endpoints, and you're going to tell me the coordinates of the other endpoint.